Okay, so for our last unit for this year, we're going to start looking at triangles. So specifically for this year, we focus on right triangles. So remember that a triangle, tri meaning three, is any shape that has three angles, right? So 1, 2, 3. So triangles can come in many shapes, right? We could have a triangle that looks like this. We could have a triangle that looks like this. We could have a triangle that looks like this. Triangle that looks like, well, that one's not straight, but if these were all straight lines, triangle that looks like this. Oh my God. Right? These are all triangles. The triangles that we are going to look at specifically are right ones. And what makes them special is this box in the corner. What this box tells us is that that angle is 90 degrees. It's what we would call a right angle. So all right angle triangles or right triangles contain that 90 degrees. It's not always in this corner. You could have a triangle that looks like this. That would also be a right triangle. Or even if we turned it. Right, that's still a right triangle because it still has that 90 degrees. That's the golden ticket here when it comes to right triangles. And so when we look at those triangles, we're looking at two different things. We're looking at the angles and we're looking at the sides. So when we're looking at we're going to start by just looking at the sides. So we label the angles using capital letters. So each corner gets a capital letter A, B, and C. And the really important one is the one that goes here, the one that attaches to the right angle. And that's really important because that means that the angle that's across is our C. And the C is the most important angle to measure. The A and the B don't matter as much. It doesn't matter if we call this one A or B or if we call this one A or B. What matters is the C. The C is what we call the hypotenuse. And the hypotenuse is the most important side. And that's because that's the side that Pythagoras kind of figured out was related to the other two. It's the longest side in the triangle. So it's always the longest side. And it's also always opposite from the right angle. So if we draw an arrow out from the right angle, we're going to hit that hypotenuse. So what Pythagoras figured out was that that longest side, that C, is going to be equal to the sum, so we add the other two sides. So if we square both of the other two sides and we add them, they're going to be equal to the longest side. So we could also flip this. We could also write this like this. C squared equals A squared plus B squared. These are the same formula, but essentially they're representing that relationship, that our C, the longest side, is going to be equal to the two shorter sides squared and then added together. So we can use that. If that is a rule, it means it applies to any right triangle. So we can use it for these triangles. So our first step is to always figure out where our C is, right? Because that's the most important side. So I start at that right angle to label my C, right? So this is side C. So remember that because this is a right triangle, we know that all three of these sides are related. So if I know two of them, I can find the third. So we know that C squared is equal to A squared plus B squared. So in this case, I've got that A and B. Now remember what I said, it doesn't really matter which one you make which. What matters is C. C has to be the side across from the hypotenuse. C has to be the hypotenuse. The rest of them don't really matter. So what we're going to do is we're going to take those and we're going to substitute them into our formula. So A, 18, gets squared. And B, which was 15, is going to get squared. I need to pull up a calculator. So here, this is where we're going to start calculating. So we're going to go, well, my C squared is going to be equal to 18 squared, and I'm using my x squared button, so 324 plus 15 squared, 225. So 225 plus 324 is 549. Now, we're not done yet because this c isn't by itself yet. The c is squared. And so I get rid of a square, just like I would get rid of an addition using a subtraction or a multiplication using a division. We get rid of a square using a square root. So I got to square root both those sides to get c by itself. So 524 square rooted, 23.4. And this is where all of your calculators are going to work a little bit differently. Some of them you put the number in first and then press the square root. For some of them you have to put the square root in first and put the number inside. So be aware of how your calculators are going to look different. So same thing here. We want to figure out the missing side. So because we know this is a right triangle, we know that Pythagoras applies, which means that if we know two of the sides, we can find the third, because we know that c squared equals a squared plus b squared. So first step is always to find out which side is c, right? Because they're not always going to be labeled for you. Then you have your a and b, and it doesn't actually matter which one you put where. So I've got my a here, and I've got my b here. So then we're going to fill in. So this time I actually know what c is, right? I know that c is 12, so I can fill in that 12. My a here is an x, and my b is an 8. So now we're going to solve this. 12 squared is 144. 8 squared is 64. Now remember that when we say we're going to solve it, what that means is we want to get x by itself on one side, and it has to be positive. So we're going to move things around in a way that's going to either make x positive or keep x positive. So because x is positive here, I need to get rid of this positive 64. So to get rid of the positive 64, subtract it. So we're going to go minus 64 on both sides. We're going to go 144 minus 64 is 80. And it doesn't matter what side this is on, because saying 80 equals x squared is the same as saying x squared equals 80. We can write that either way, and they mean the same thing. So once again, we're not done because that x is still squared, so we got to square root it. And so we're going to go 80 square rooted is 8.9. And for the most part here, we're going to be rounding off to one decimal place. And if you can get a whole number, that's great. So same thing here, we need to find that hypotenuse because that's the important side. And then our a and b don't matter as much. So this time, so remember c squared equals a squared plus b squared. So c squared here, c is 7.2. A is a because there's no number there, so we can just use the letter. You could also use an x if you prefer having x as your variable. And now we need to solve this. So 7.2 squared, 51.84. 5.3 squared, 28.09. And once again, we're going to move things around in a way that it's either going to make a positive or keep a positive. So because it's already positive, we're going to keep it here, and we're going to move the positive 28.09. So we're going to subtract that to get rid of it. And I'm actually going to get rid of this line in the middle because it's confusing. Remember, we're doing that on either side of that equals. So now I'm going to have a squared 51.84 minus 28.09, 23.75. And we're not done because that a is squared, so we got to square root it to get rid of that square. So a is 23.75 square rooted, so 4.9, because I'm going to have to round that up. So if you didn't catch that, because this is an 8.7, we look to the 7 because it's higher than 5. We're going to round up that 8 to a 9. So 4.9. So one thing you can always check here is make sure that when you're done this, your C is always going to be the longest side. So we see here 23 is bigger than both of these, so that's probably right. Here, 8.9, smaller than 12, so 12 is the biggest number. So it's kind of a quick check to see if we've done your math right. If you get some crazy number that doesn't make sense, it tells you that something's wrong, right? Maybe you forgot to square root it. If you're, for example, here, if I had gotten 23.75, that doesn't make sense because it's so much bigger than my hypotenuse. So that's a good check to do to see if you've kind of got the right idea. So we can also use this to check to see whether a triangle is right or not, because we know that if a triangle is right, a squared plus b squared will equal c squared, right? Or c squared equals a squared plus b squared. Remember, we can use either form of these. It doesn't matter. They're the same formula. I've just moved them around. So if this is a right triangle, this will be true. So remember, I know that the longest side is always going to be my c, right? So in this case, this would say, well, 25 squared is equal to 7 squared plus 24 squared. Remember, these two don't matter as much, but c is the important one. So 25 squared, 7 squared is 49, 24 squared, so what is 49 plus 5, 26? 6, 24. So we check and see, is this statement true? Does 625 equal 625? Yes. That means this is a right triangle. If those two numbers don't match up, that means our triangle is not right. So we're going to try that again. So same thing, if this is a right triangle, then c squared will be equal to a squared plus b squared. So I look at this and I don't actually know what the square root of 85 is, so I might need to check that before I get going, because I need to know which side is the longest, right? Because that's going to be my hypotenuse. So here, the square root of 85 is 9. So this is my hypotenuse. This is my c. So c, the square root of 85 squared, is going to be equal to 6 squared plus 7 squared. Is this true? So I just did that, the square root of 85. So it's the square root of 85 squared is 85. So fun fact, a square and a square root will cancel each other out, and you'll get the number on the side. 6 squared is 36, 7 squared is 49. So 36 plus 49 is 85. So because those numbers are the same, that means this is a right triangle. I don't know where that 8 came from. So here, which is my hypotenuse? It's going to be the longest side, so that's my C. That's the one that's the most important to pick out here. So I write the formula out every time, especially when I'm starting, because it helps me to remember the formula, right? The more that you can remember it, the less mental work you're going to need to do to try to find it and pull it out. So 12 squared, 8 squared, plus 10 squared. So 12 squared is 144, 8 squared is 64, 10 squared is 100. You can always use your calculator to find these. You're not expected to remember them, so I can go 12 squared, 64, or oops. Where's my clear one? 8 squared and 10 squared. Okay, so we're going to get 144 equals 100 plus 64, 164. Notice how I got different numbers there? That tells me that this is not a right triangle. It's still a triangle, just doesn't have a right angle in it. Probably has something more like a like 75 degree or 100 degree. I don't really know, but it's not 90 degree for sure, because if it was 90 degree, it would follow Pythagorean Theorem, and it doesn't, which means it's not a right triangle. We can also use, this is actually really common. Pythagoras is one of the more common mathematical formulas that gets used in everyday life, because there's a lot of things in everyday life that are 90 degrees. So poles are mounted at 90 degrees, house walls, 90 degrees. So anything leaning on those or tied to those will be a part of a right triangle. So here we've got an electric pole sitting on the ground. And so one thing we know about these is for them to stay stable, they are going to be connected to the ground at 90 degrees. So we've got a wire attached to it that's also attached to the ground. So the only way that that can happen is by creating this triangle. We know the pole is 20 feet tall. So here's my pole, right? So that pole is 20 feet. And it's a 24-foot wire. So that means this wire is 24 feet long. Let's know how far. So it wants to know the last side there. So if we know 2, we can find the third because we know this relationship. So I know that 24 squared, because remember that across from that right angle is going to be my C. The other 2 don't matter as much. So x squared plus 20 squared. 24 squared, 576. X squared plus 20 squared is 400. Remember, we got to get this x by itself, which means we got to get rid of that 400. So 576 minus 400, 176. And then if I was just put this 176 in here, that wouldn't make any sense, because remember that C has to be the longest edge. So if that happens, that's a sign to you that you've missed something or you've done something wrong. So go back and check. So I see that I've actually forgotten to do my last step. I need to get rid of that square with a square root. So we're going to go 176. Oops. Square rooted 13 point. And once again, we're going to round to 1 decimal place. So I'm using this first decimal place, and I got to look at the next number. So I'm looking at this 6 because that's bigger than 5. That 2 is going to become a 3. So it's going to be 13.3. And because this is a situational question, right, that number needs to have meaning. It doesn't mean anything without a unit. And up here where we're just practicing, that's okay. But down here where this is part of a situation, it needs to mean something. So we're using feet. So this is going to be feet. So that answer here is that our wire is sitting 13.3 feet from the base of the pole. Now, TVs are funny, so any rectangle, so fun fact, if you have a rectangle or a square, what you actually have is 2 identical triangles. And in a rectangle, every corner is a right angle. So what you actually have is 2 distinct, identical right triangles. So we can use Pythagoras a lot of the time when we're dealing with rectangles as well, because we're actually dealing with 2 identical triangles. So what do we know about this? We know that it has a length of 36 inches and a width of 19.6 inches. When it says what's the length of its diagonal, the diagonal is the distance across the middle of the TV. So essentially it wants to know what's the length of its hypotenuse, right? Because across from those is that C. Now, in a rectangle, because all the sides are the same, doesn't matter which triangle I'm using here, because my C is going to be the same in both of those triangles. What I do know is that my C is my unknown here. And so I'm going to sub that 19.6 and that 36 in. So 19.6 squared, 384.16. 36 squared, 1,296. So we got to add those together. So plus 384.16, 1,680.16. Am I done? Does that make sense? If for that diagonal to be that big? It is the biggest side, but that's significantly bigger than either of its other sides. So your number should still make sense, right? We're not like, it's not some crazy shape. That line still has to make sense, and that's a really big side for those two small sides. So once again, it's because I've forgotten to get rid of that square. Get rid of a square, I got a square root. 40 point, now notice here, 98, right? So because I've generally been using, oh, this wants it to the nearest inch. So notice that in the question it says nearest inch. So I'm actually going to the 0, which means I got to look to the 9. So it's actually going to be 41. And once again, it's going to need a unit because we're looking at an actual question here. So the diagonal, the television's diagonal, so the distance across the middle of the TV, is that how you spell it? Nope. Diagonal is 41 inches long. Alright, so that's what we're going to be playing around with today. You guys are going to have an IXL assignment as well as a written assignment. Have fun!